What's up, guys? Today we're taking a look at part 2 of the original Fuzzface build. If you didn't check out part 1 and you wanna, I'll link it down below. I'll also give you a parts list in the description, complete parts list, and I'll also upload this diagram to MediaFire so you can download it and have a nice printout for yourself. First off, I want to say this board is the exact same board in part 1. There's just I was looking at some schematics, and the PNP for the germanium and the NPN, it's just a matter of switching polarity on these two blue resistors and then changing the polarity on the battery. So the germanium uses a positive ground, and that's the PNP. The NPN, which is the silicon, uses a negative ground, and I'll explain that as we go along. I did read that, and I'm going to try it out. It doesn't matter. It's just a matter of swapping positive to negative with the two capacitors and the battery connection, so it's not that big of a deal if it don't work out, but I'm curious if it is. So first things first, this silicon transistor up here is a plastic one. It has a flat on it. Leg 1 is always going to be on the left, leg 2 in the middle, which is your base, leg 3 is your collector, and then over to the right, we also can have germanium and silicon transistors that are metal. Now, the way to identify what legs are what, there is a little tab right up here in the corner. I have an arrow drawn to it. That is leg 1. So the tab goes right by leg 1. And the easiest way to remember leg 2 as its offset, think of it as the peak of a triangle. Leg 3, and by the way, leg 2 is still your base. Leg 3 is parallel to leg 1, and that's your collector. Moving down here, this is a capacitor. And there's many capacitors out there. This happens to be a radial where the legs come out the bottom, and the way to note the polarity, because these are electrolytic, the longer leg is positive. I have that labeled. There's a negative stripe usually on the one side that has a negative symbol. If the leg isn't longer and it doesn't have that stripe, the little crimp or divot is your indicator that that's positive. Okay, so we're taking a look at the board now. Germanium transistors, PNP type, positive ground. Silicone, NPN type, negative ground. The difference here, if you watch my last video, you'll note that the layover I did, the positive sign was on the left-hand side here. If you're doing silicon, you want the positive to land on the right. Same thing with this capacitor. You want it to land on the right. This capacitor down here, you don't need to worry because it is not polarized. Doesn't have polarity. You put it in any way you want to put it in. So with that said, let's go over the values here. 2.2 UF. UF stands for microfarad, 63 volts. That's the cap that you want to put in there. 22 UF, 22 microfarad, 25 volt is the second cap you want to put. Make sure you get your polarity right with whatever you choose to use. For this capacitor, it's 0.01 microfarad, 250 volt. I did want to include here because this is what you want to really search for. You want to search for what was in the original one, and that was a 10 NF. NF stands for nanofarad. It's a metallized polyester film. It's 160 volts. If you can't find that, type in 10,000 PF. That stands for picofarad. Metallized polyester film, 160 volt. Coming back up to the board here, you're going to see 3 resistors. Now, what they did in the earlier days, they had this 33K. The capital K stands for kilo ohms. That was up here where this 330 ohm resistor is. And then they had a 470 ohm resistor in the middle. So they did away with the 470 and they replaced it with the 330. And they took the 330K and they put it in the middle. They put the 330 ohm resistor first, which is color code orange, orange, brown, silver, gold, and there's some other ones that indicate tolerance. Silver means 10% tolerance. I went with gold for all the resistors. I also went with as many carbon resistors as I could, although I couldn't get like 2 of them. I think it was the 33K and the 8.2. I had to go with the newer ones. So it is what it is. These are all half-watt resistors. So the next one is the 33K, and then that's going to be an orange, orange, silver. I went with gold, half-watt, 8.2K. To the left here, you'll see the color code gray, red, red, silver. Again, I went with gold, half-watt resistor. Transistor, okay, there's one more resistor here, which is the 100K. And by the way, these resistors do not have polarity, so you don't have to worry about which way they go in. So this 100K resistor, the color code is brown, black, yellow, silver. It's half watt. Moving to the transistor, we're looking at this hole, and this hole. Here's your emitter, pin 1, base, pin 2, collector, pin 3, leg 3, whatever you want to refer to it. I noted transistor and I put 3 arrows to the holes here. This one, you're going to have to flip your transistor around because if you notice, pin 1, E for emitter is here, base, and then collector. Moving down to the foot switch. This is a double pole, double throw foot switch. You got 3 legs on the one side, left side, 3 legs on the right side. First thing you want to do is take a jump wire and jump the upper left-hand corner to the very, and that's the first leg, all the way down to the 3rd leg on the right. So you want to solder that in there. Then we're going to move over here to the input side where your guitar is going to get plugged in. This right here is indicating a stereo 1/4-inch female jack, as you'd plug your guitar into your pedals, your amp, headphones, whatever. So you would find this kind of female jack for plugging headphones in that have a 1/4-inch input. Break it down, it's very simple. Right here, where my mouse is going up and down, is the sleeve. That is considered the ground. This little V notch here is the ring. So that would be the right side for the right speaker. The next upside down V would be your left channel for your left speaker. That's the easiest way I can explain that. So what you're going to want to do, bottom right hand corner of your foot switch, run a wire down to the tip. From there, you're going to take a wire, you're going to solder it from the sleeve of your stereo, TSR, 1/4-inch female input, and we're going to come over here and you'll notice that this is a mono 1/4-inch female jack, and this is your output side. So your guitar would get plugged into here. It completes the circuit. Make sure to pull it out so it doesn't drain the battery. Then your other cable will run out to your other pedals or your amplifier. From the right hand side, you're looking at leg 2, the middle pin. You're going to come down and you're going to connect the wire to the V, which is the tip on a mono. So that would indicate a left speaker. It's the easiest way to remember that. Now your sleeve, don't forget, we're going to connect both sleeves together right here with one wire. Once you got that connection done, you're going to take this lower left, it would be the third leg on the left side, and you're going to run that down to the sleeve, and you're going to solder that in to the sleeve on your stereo jack. From there, we solder another wire from that sleeve. We come up, and now we are at our potentiometers. So that brown wire is going to go to lug 1. Now, the way you tell lug 1, 2, and 3 on these, we're looking at the back side of the potentiometer. Leg 1 is always on the right hand side looking from the back. Then it's 2 and 3. If you turn it around and you're looking at it from the front where you actually turn it, lug 1 would be on the left. So we're soldering in to leg 1 of the volume. We're bringing that over to lug 1 or leg 1 of the fuzz volume pot. Now it's important to note 1K linear for the fuzz is to be used for the potentiometer, and then you're going to use a 500K audio taper, log, or logarithmic. So then from lug or leg 2 on the volume pot, the blue wire, we're going to come down and we're going to run that into pin 1 on the right side of that switch. Then lug 3 or leg 3 of the volume pot, yellow wire, we're going to follow down. That goes into our circuit board. Now if you notice, there's 1, 2, 3, 4, 5, 6, 7. So that's going to be in the 7th position that wire is going to go to. Moving over, we already did leg 1 on the fuzz pot. So we're looking at leg 2. It's the green. We come down and we go to position 4 on the board. Leg 3 on the potentiometer for the fuzz. This rusty orange or whatever you want to call it comes over, and then you simply count down 1, 2, 3, 4, 5, 6th position. So what are we missing here? Well, we're missing position 1. So there's a red wire coming out, and that comes down and goes to the center leg, the second leg on the foot switch, right in the middle on the left hand side. Come back up, take a look, and we're going to go from position 2, unless we did this one already, I forget, the purple down to leg 3 on the left side, and then position 3, that's your ground. So that's going to ground the circuit board to your chassis. You can also take and run this ground down to this sleeve to ground the circuit. And I just have ground, so I don't know where you want to run that to, but you can ground it to the sleeve, or if you have a metal chassis, you can ground it to your metal chassis. Okay, so then that's going to take us to position 1, 2, 3, 4, the 5th position. Now we're going to look over here at the battery. So you have a red and black wire that comes off your battery. Now for the silicon, the red, the positive, is going to go into the board. The negative is going to come down and go to the ring. If you're going to use the germanium PNP type, you're going to have a positive ground. So you're going to have to flip polarity on your battery connector. So your negative will be over here, and the black wire of that battery connector will go into your board. Your positive will be here, and it'll run down to the ring. So that's about the only difference between germanium and silicon with the wiring.